600-kilogram man launched from a 100-meter tall cliff with the initial velocity of 75 kilometers per hour, 22 degrees above horizontal. At the same time, the boat, with the initial velocity of 10 meters to the right, accelerates towards the cliff at 5 meters per second squared. The question wants to know how far the boat should be placed for the man to land on the boat. In order for this question to work, we need to assume that there's no air resistance and energy is conserved for the boat. Event 1. Man launches from cliff and boat starts accelerating. The motion for the man is uniform acceleration down, uniform motion right, going up at an angle and slowing down. The motion for the boat is uniform acceleration left, going right and slowing down. Event 2. Man lands on the boat. Now we are going to draw a diagram based on the givens the question gave. Draw a man on a 100-meter tall cliff, then the boat x1 meters away from the cliff. Then label the angle of the initial velocity of the man. The x1 is the initial position of the boat, which is what we're trying to solve for. Then include a compass with the positive directions, which would be up and right. Next, we will be labeling the givens onto the graph. This will make it easier to solve the problems. Now we can start solving. The givens of the man is collected, which are his mass and initial velocity. Then, to solve for the time, we have to split the man's givens into x and y components. Finding the time would help us connect the man's and the boat's motion. Since the time it takes the boat to land will be the same as the time the boat gets to travel. Therefore, by finding the time, we can get the displacement of the boat. Starting with the y-axis, the givens are the mass of the man, acceleration due to gravity, and y component of the initial velocity of the man, which we get by using trig. Using the following Big Five equation, we can get the time. Notice that we get two time values, and we reject the negative one since it is before our motion. After we get time, move on to the x-axis. Since the x-axis is uniform motion, we can just use displacement equals velocity times time. There's no need for Big Five. We get the displacement being 103.9 meters to the right, which is x2, where the boat needs to be at event number 2. Now we move on to the boat. The givens for the boat are the acceleration of the boat, initial velocity, and the time which we solved in the previous section. By using the Big Five equation, we can solve for the displacement. The displacement for the boat will be the initial position of the boat, which is what we're trying to solve, and x2, which we solved in previous question, where the man will land and where we want the boat to be at the end of its motion. Therefore, we can just rearrange our equation into x1, which is what we're trying to solve for, equals to the displacement of the boat plus its final position. Therefore, we get an answer of 1.2 times 10 to the power of 2 meters to the right of the cliff.